In this problem, we want to synthesize this compound cyclic from this compound. So here what I'm going to do is I'm going to disconnect this and trying to figure out where this can come from. So I'm going to disconnect right here. So I can think of a reaction in which having an acidic product here and attacking on a carbon that had a good leaving group. So I'm going to draw something here. I'm still keeping my cyclic structure so that you see better what I'm doing. So now I'm going to have a bromine, for example, here. And I can think of making this and having this reaction and SN2. So to get here, then I'll need to make, and then I'm going to draw that straight. I'm going to just unfold it. And this is going to be, that's the aldehyde that I want, and then I have 1, 2, 3, 4, and 5. So 1, 2, 3, 4, 5, and I have a bromine. So that I'm going this like going backwards, right? And I see that here I have a double bond. So how do I make this? And I have an alcohol. So I have a couple of changes from this to that. One thing that I need to do is reduce this to an alcohol. So, which is, in other words, going backwards, it is a reduction, right? So coming from that. But when I do this way, moving forward, it will be an oxidation. So now, this can come from the alkene. So let me do that in just one step. Here, if to add the bromine here, I need to add across the double bond H and Br here. This is an anti-Markovnikov regioselectivity. Means I need to use HBr and peroxide. That way I will ensure to have the bromine at the end. The next step, I need an oxidation. That is a primary alcohol in a 1-aldehyde. Here you need to be careful in choosing the oxidizing agent. Use a mild oxidizing agent such as pyridinium chlorochromate, so PCC, or DMP, or DMSO. That way it will stop at the aldehyde. If you did Jones here, you're not going to get that. You're going to go straight to the carboxylic acid, which you don't want. So you don't want this. You must use one of the mild oxidants. Once I am here, then how do I get this anion? See, remember that this is your alpha hydrogen. So you can use a base. And here to use, to get that base, we need to remember that pKa of the hydrogens next to a carbonyl aldehyde or ketone are between, say, 19 and 20, that pKa. So definitely ethoxide is not a good option because, say, if I use ethanol, and if I use ethoxide, the pKa of ethanol is 16. So, and if this is, say, 19, that is not going to work. So I need something stronger base. So than that. So typically you can use sodium amide, for example. Sodium amide is a conjugate base of ammonia, and here the pKa is 38, so more than enough to get that product. So that way I am ensuring that I can form I'm gonna make it better, the anion here, and you will have, sorry, the nucleophilic attack here. And once you have that, you have close that, and again you count 1, 2, 3, 4 and 5, 5-member ring. So what I did in the analysis here was disconnecting that. So disconnection approach, we're going to call that. So in these pieces are like symptoms. We say, so that fragment needed to have, I need to have a carbon ion there and a good leaving group on the other end. Then I unfolded that this has to come from these aldehyde. And looking at the structure here, I need forming the aldehyde from the alcohol requires a mild oxidizing agent. And having the bromine at the end, I need to have an anti-Markovnikov addition to the double bond here in the reactants.